Hey everyone, let's understand what is aggregation and composition in Python. So composition means one object owns another object. So if the owner is destroyed, the part should be destroyed as well. And in aggregation, the objects are loosely coupled. That means one object uses another but does not own it. So if the container dies, the part can still exist. So let's understand this with the help of examples. So we'll start with composition. I'll create a class and call it computer. Let's define a constructor so that we can construct the computer object. We'll pass self and brand. Let's do the assignment. So self.brand equals to the brand that we'll receive. Let's define another instance method to display the information. We'll print the computer brand self.brand. And let's create one more class and let's call it CPU. We'll define the constructor. Let's pass self here. And here I'll hardcode few values. So let's say course, I'll take it as 4 and self.speed, I'll take it as 3.4 gigahertz. Let's create an instance method for this as well to display the info and I'll name it as display. We'll pass self and we'll print CPU info self.course, self.speed. Now here with every computer object that I create, I want it to have the same CPU. So basically every computer is going to have their own CPUs. And for that we can go ahead and create a CPU object inside the computer class. So here I'll give a variable as CPU and we'll create the CPU object here. And with the help of this, we can also access the display method of CPU. So we'll display the info as well over here, .display. So here now because we did this, the computer class is creating the CPU object inside it, right? So that means if the computer is gone, then the CPU goes with it. So this is like a tight, strong relationship. It's very tightly coupled. And it is also perfect for things that don't make sense on their own. So for example, a CPU makes no sense without a computer. Let's go ahead and test it out. So I'll create an object for computer class. And let's give a name as del. And if I call this method show method, so c.show, let's save and run this, we get the information. We get the computer information and we also get the CPU information. Now if I go ahead and delete the computer object, the CPU object will get deleted as well. So let's go ahead and do that. So if I do del c, this is going to delete the computer object, but we also need the confirmation that the CPU object was deleted as well. So for that, let's go ahead and use a dunder method which can confirm us that the CPU object was deleted. So I'll use the magic method del here, which is for delete. We'll pass self and I'm simply going to print here that the computer object has been deleted. Sorry, this is CPU. So CPU object has been deleted. We can also add the same in the computer class as well. Let's save this, and now the moment this line gets executed, we should be able to see these two messages. Although we are deleting only computer, but the CPU will also get deleted because the computer is actually creating the CPU object, and that is why they are tightly coupled. We'll run this now, and if you see here, we first created the computer object and it also created the CPU object, and we got the information by this method, and after that we are deleting the computer object. So we got the confirmation that computer object has been deleted, but if you see, the CPU object also got deleted. So this is what happens in composition. Because the computer class was owning the CPU class, the moment we deleted the computer object, the CPU object got deleted as well. Now let's talk about aggregation. So unlike composition, in aggregation there's a loose relationship between objects. So even though one object uses another but does not own it. Let's go ahead and do an example. I'll remove this for now. Let's create a class and name it as book. Let's define a constructor. We'll pass self and the title of the book. Do the assignment self.title equals to the title that we receive. Let's define another class and call it library. We'll define a constructor to construct the library object. Pass self and then we'll pass books. Let's do the assignment. So self.books equals to books. And this line actually shows the aggregation as we'll be passing the books from outside. Let's write another method to show the book. So show books, we'll pass self and then we'll run a loop on the books. So for book in books, it should be self.books, self.book, and then we'll print the book name as in the book title. Now let's go ahead and create few objects for the book. So I'll create book 1 and let's give a book name. I'll give 1984 and let's create another book and let's give a book name here as well. I'll give To Kill a Mockingbird. And now we will go ahead and construct the library object. So basically books are created outside the library. Okay, now we'll go ahead and create the library. And in the library, we can pass the book data. So book 1 and book 2. And now let's call the show books method. Now let's go ahead and run this. So in the output, we can see that both the book names are getting displayed when we are displaying the library. But what if I delete the library? And after deleting the library, I want to check if the book still exists or not. So let's just print book title, and I'll also print book 2 title. So just by deleting the library, the books should still exist because they are not tightly coupled as I mentioned. So but to get the confirmation that the library was deleted, let's just go ahead and in the library class include the del dunder method. So I'll define the del method here so that the moment library is deleted, this will get triggered and it is going to give us a confirmation message that the library was deleted. And after that, we are anyway checking if the book exists or not. So we don't have to include this method in the book class. So here I'll pass self. Let's print a message and we'll say library was deleted. Let's save and run this. So these book names are coming from this line, and then the library was deleted and we got the confirmation that the library was deleted. But even after the library was deleted, we were able to access the book titles. That means books were not deleted. So that's all for the session. So just remember that in composition, one object cannot exist without the other. So the parent fully controls the child's life cycle, the example that we did with the computer and CPU. And then in aggregation, the contained objects live independently and objects can be reused in other contexts. So that's all, and I'll see you in the next one.